All right, only 2 more examples to go. The first thing I'm going to do actually is notice that this x on the inside is not alone. So I'll take out a -1 and just get an x. 2 divided by -1 is -2. You can check if you bring the -1 in, you're going to get a -x, and then you're going to get a +2. So that's how you know you've done it correctly. Now, if you don't know how to do this, I would say watch the previous video, but I can't graph these. I don't know, like it's not intuitive, I said before. It's not intuitive, the numbers that I would choose here. So what I'm going to do is use the base and make it the exponent. I'm going to not graph, but I'm going to create the points for an exponential. Because it's a 2, I'm doing a 2 here. Now we've done this one so many times. 0, 1, 2, and 3. So 2 cubed is 8, so you put it into here, right? So 2 cubed is 8, 2 squared is 4, 2 to the 1 up here is 2, 2 to the 0 is 1, and then these are all the negative ones that should bring things to the denominator. So now that we have that, we can actually invert it, and when you invert, you are doing you do what undoes this. What undoes an exponential is a logarithm. And again, we haven't learned that yet, but we can still actually graph this. So now we can invert it. So I'll just write inverse. And all we need to do is put our numbers on the other side. So 8, 4, 2, 1, 0.5, 0.25, 0.125. And that's how you're going to graph a logarithm. Now, that's what we did in the previous one. We just graphed those points, but then the third step would be to do the rule. So we're going to have some sort of rule now. So for the x here, it says times by 1, so we're going to divide by -1. It says -2, so we're going to add 2. And for the y, it says times by -2, so I'll do that, -2y, and -1. And then with this, x divided by -1, we've done this before, that is just the same thing as -x. So at this point now we need to, I think we took out a calculator for some of these, but we need to put these in. Now for the y's, you don't need to. That should be done without a calculator. -2 times 3 is -6, -1 is -7. And then we've got 2 in here, -4 minus 1 is -5. -2 minus 1 is -3. 0 minus 1 is -1. 2 minus 1 is 1. You can see a pattern here. 7, 5, 3, 1. So this is going to become a 3, and this should become a 5. So 6 minus 1, yeah, it is a 5. So that one was done without a calculator. This one, you can do some of these without a calculator. So -8 plus 2 is -6. And -4 plus 2 is -2. -2 goes into there, plus 2 is 0. -1 goes into there, it's going to be a 1. And then the other ones can require a little bit of a calculation if you want. So I can put a negative, and then what's the number? 0.5, 0.5, and then plus 2. And then you can go negative 0.25 plus 2, and then negative 0.125 plus 2. 0.5, 0.75, 0.875. So 1.5, 1.75, 1.85. Look at where this is heading. It looks like it's getting closer and closer. Can't do a star apparently, to 2. So it's going -6, -2, 0. We're climbing up to 1, to 1.5, to 1.75, to 1.85. We're getting closer and closer. I think it's actually 875. We're getting closer and closer to 2. So let's keep that in mind. Now we can plot these points. I like to start at the bottom where the whole numbers were. So it's -6 and -7, -2 and -5, 0 and -3, 1 and -1, and then 1.5 and 1, 1.75, all the way up to here, and then all the way up to here. So That's the kind of graph. And look, it's getting closer and closer to 2. So we've got some sort of boundary here. This is a vertical asymptote at 2. And so you get some drawing here. So that's what you get. It's probably worthwhile to do some domain and range. Now remember, domain is left and then right. Range is how far down and then how far up. So how far left does this thing go? Well, it goes forever to the left. How -8, no, -infinity. How far right does it go? Well, it goes to 2, goes closer and closer and closer to the x value. Remember, this is the x. Gets closer to the 2 line here. So we will go as close as we can to 2, but we can't cross it. So I'm going to put a round bracket to say it never actually reaches 2. How far down does it go? Well, it goes down forever and it goes up forever. This thing will head down forever and it will head up forever. So that's my domain and that's my range. So there's obviously a lot of work that goes into this. I'll zoom out here if you want to pause it, but the notes probably that are online, the PDF is one that probably looks a little bit nicer. So we do have this graph. If you need to pause it there, and we've got one more question to do. So this is like the biggest question here. There's a ton going on. It is not super easy, that's for sure. What makes this one maybe a little more challenging is that there's this -1/2 that's kind of stuck there. So we're gonna have to factor that -1/2 out. And if you divide this, like you have to divide that by -1/2 and divide that by -1/2. Negative and negative is a positive, so that part's okay. But 2 divided by 1/2 is actually 4. Because when you divide by 1/2, you're actually multiplying by 2. And you can check, you can put this back in. That'll be a -1/2 x, and 1/2 of 4 is 2, and it's negative. So that actually works. Okay, so how do you graph a logarithm? Well, first you gotta start with the base function. And in this case, the base is 3. So I'm going to do 3 to the x. Right? The base is 3, so I did a 3 there. Not because of 3 out there, that's not why. But it's a base of 3. This is log base 3. Now, I can create a table. -3, -2, -1, 0, 1, 2, and 3. And then you can put this 3 into here. So 3 cubed, we've done this before, is 27. 3 squared is 9. 3 to the power of 1 is 3. 3 to the 0 is 1. And then you get 1/3, which was 0.333. And then 3 to the -2 is the same thing as 1 over 3 to the 2, which is 1/9. So it's 0.111. And this is 0.037 repeated. So that is in a couple videos ago we did do that. So keep that in mind. If you didn't catch that, you can watch that video. So that's helpful only because it allows us to take the inverse. So if we do the inverse, then what we're actually graphing or finding is log base 3 of x, which is good. That's what we want. We want a log base 3. So I can put the -3, -2, -1, 0, 1, 2, 3 onto that side, and then the 27, 9, 3, 1, 0.3 repeated, 1, 1 repeated, 0.037 repeated. So I've inverted it. Lastly, I need to do a rule. So if you need to pause this here, you can to kind of catch up, or you can continue watching. So the rule here, I'm just going to zoom in. Get rid of this, get rid of this. Rule. So for the x and y, the x, now the x says times by -1/2, so I'll do the opposite. I'll divide by -1/2. And it says +4, I will minus it. And then the y just says times by -3, so I'll go -3 times y, and then -1. And then we've done this a bunch of times in this unit, but whenever you divide by 1/2, you're also multiplying by 2. So I'm going to make this a 2x. So this is my rule. So I'll write that down here. The rule because they got to do all these transformations. 2x minus 4, negative 3y minus 1. And so now I need to create my new table based on these. So I'm not going to do all of them here. I'll just do a couple, and then I'll just fill in the rest. But it's all just done with a calculator for these other ones. And these ones, because you're not dividing, you're just timesing, those can be kind of done in your head. So for this one here, like 3 times negative 3, the y is here. Put in a 3 here, you get negative 9 minus 1, that's negative 10. And then you can put in a 2 into here, negative 6 minus 1 is negative 7. And that keeps going on, so I'll just write them down. It's negative 4, negative 1, 2, 5, and 8. And if you put 27 into here, I don't know what that is, 54 minus 4, negative 54, is it a negative 2x? I think it is a negative 2x. I don't know what happened to the negative symbol, because I was dividing by negative a half. So 27 times negative 2 is negative 54, minus 4 is negative 58. And then put a 9 in here, negative 18 minus 4 is negative 22. And you can keep putting those in, negative 10, negative 6. And these ones require a calculator, so you could just bring out your calculator. Or maybe you're just really good at using fractions, which is also fine. So negative 2 bracket 0.33333 minus 4. So negative 4.666. And if you do the other one, you get negative 4.222, and you get negative 4.074. So you're getting closer and closer and closer to negative 4. So anyways, we can plot all of those points now. Obviously I can't do the first one, and I can't even do the second one, negative 22. So the first one I can do is negative 10 and negative 4. And then negative 6 and negative 1. And negative 4.66, so this is negative 4, 4.5. Negative 4.66 is 2. And 4.222 is 5. And really close to negative 4 is going to be 8. And so you should get this graph now. This is really hard to do here. In fact, it's getting really, really, really close to, like we said, negative 4. So that's what you end up getting. I realize there's a lot of work that goes into these. This is like a 13-minute long video, and it's only 2 questions. So domain, how far left and then right, and then how far down, and then how far up. So left would be negative infinity. How far right does it go? Well, it goes up to negative 4, but it never crosses it, or never even touches it, so that'll be around. And how low will it go? It'll go down forever, and it'll go up forever. So negative infinity and positive infinity. So that's my domain and range. So there is the graph. But like I said, the notes show it a little bit nicer, so you might want to go back to those. But hopefully this gives you a bit of an idea of how to graph logarithms. You start with the base, the exponent, you switch the x and the y to get the log, and then you can do all the transformations to it.